What up, calculus students? Coming at you. This should be another shorter homework, but don't worry, the last two are much longer. Okay, great. What do we learn? Antiderivative of e to the x is e to the x. It makes sense. There's nothing fancy going on. It's just a derivative we know, so it's an antiderivative we know. What also do we know is that the antiderivative of x to the negative first, you can't use the power rule. It's the only power you can't use it for. Any other power you can. But a negative first power, we remember that the natural log function has a derivative of 1 over x, so it goes the other way. Don't forget plus c's, and we need an absolute value because of the fact that if we're going backwards, we can plug in any value for x into 1 over x, so we want to plug in any value except for 0. Into log x, we have this absolute value. This one drives it home, the whole power rule fallacy. The power rule works for every power except the negative first power. This antiderivative is log absolute x, but this antiderivative is x to the negative first times negative 1. This antiderivative is x to the negative second times negative a half. Log absolute x plus negative 1 over x plus negative 1 over, leave the 2 down, move the x's, plus c. Okay. This is a good one. I don't want to really talk about why this antiderivative is negative e to the negative x right now. I'm going to talk about that in a second. E is just a number. This is like one that pops up sometimes on tests and tries to trick students. It's kind of a jerk question. Sorry. But the antiderivative of e to the x is e to the x. The antiderivative of e to the negative x is negative e to the negative x. I'll explain more why later. E is just a number. The antiderivative of a number is a number times x. That's like designed to be a trick and to catch students off guard. If you have a constant, just like with all of the other power rules, leave the constant. Don't worry about the constant. 3 stays. The antiderivative of a negative first power, log absolute. The 4/5 stays. The antiderivative of negative first power is log absolute. There are some log properties that we could use to like combine these two, but I don't want to get into it. It never shows up on the AB test. Maybe we'll talk about it on lesson 4 of this unit, but for right now, we're good. All right. Now, that was 1 and 2. Here's the third thing that you learned. What if we have what is a simple composition? For example, I'm taking the antiderivative of f prime of ax plus b. Now, try to like catch you guys off on things. It's got to be ax plus b. It's got to be x to the first power, or else this doesn't work. If it's x to any other power, there's got to be some other technique. Most likely simplification is the technique you're going to use, but there's going to be other techniques we're going to learn in the future. It's got to be x to the first power. And what we talk about is chains and understanding chain derivatives. The key thing to a chain derivative is like what starts in the parentheses stays in the parentheses. We call it Vegas, okay? What we're going to do is take the antiderivative of the outside, okay? Now, like theoretically here, the antiderivative of f prime we're going to say is f. But Vegas stays. So I'd have f of Vegas. Now, when we take this derivative of this, we talked about it in class, there will be an a. There will be a derivative of Vegas, which is a, that we will need to undo. You need to undo the derivative of Vegas with a reciprocal. Undo Vegas prime, Vegas. Okay? What's that look like? Well, let's start with like e to the 3x. I'm going to start with e to the parentheses, I'm going to be like, okay, the antiderivative of e to the parentheses is e to the parentheses. Okay. So we got Vegas, but when I take the derivative of e to the 3x, I'm going to have Vegas's derivative, 3. That needs to be undone. This really is just like, and I showed this in class, when we take the antiderivative of x to the fourth, why do we need this 1/5? Why is that 1/5 there? Why is 1/5 the power rule? Because the 5 is going to come down and we need to undo it. Okay, we need these reciprocals to undo these numbers that pop up. So that's the antiderivative of e to the 3x. Let's talk about 2 cosine 4x. I'm going to start with 2, which is just a concept I'm not going to worry about, cosine parentheses. Now remember, there's nothing fancy with trig functions. You're not going to use the power rule. It's just like trigs, derivatives are trigs. So the antiderivatives are trigs are trigs. So the antiderivative of 2 cosine parentheses is 2 sine parentheses. Let me move this up so it's all like in line. Okay. Derivative of sine is cosine. Okay. It's almost like you start with sine and then you figure out the sign of sine, like positive or negative. What starts in the parentheses stays in the parentheses. It'll go both ways. So we got Vegas. But we got to undo Vegas's derivative with a 1/4. The next one's the trickiest one. You got parentheses to the 4th power. Start by taking the antiderivative to the outside. I got a 5th power and a 1/5. We got Vegas. What starts in parentheses stays in parentheses. Undo the derivative of Vegas with a 1/5. So this is an important one. Like this 1/5 is needed because of this 5. This 1/5 is needed because of that derivative 5. Throwing it all together, I get 1/3 e to the 3x plus 1/2 sine 4x plus 1/25 5x plus 2 to the 5th. This one being probably the trickiest one because we had 2 things to undo. The 5 that's going to come down and then the 5 that's going to come out, the derivative of the inside, the derivative of Vegas. Cool. We encounter something like this, and a lot of us not sure what to do. The key is noticing that it's like a parentheses to the 1st power, or to rewrite it as 2x plus 3 to the negative 1st, and then 4 times 5 minus x to the negative 1st. Cool. Now remember, power rule works for all powers except the negative 1st. So for this negative 1st power and that negative 1st power, don't use the power rule. Instead, you either remember log parentheses derivative is 1/parentheses. So you know you have to use log here. Or you rewrite it as a negative 1st power and you're like, oh yeah, I got to use a log. Okay. So really, you're starting off with parentheses to the negative 1st plus 4 times parentheses to the negative 1st. Those are antiderivatives. You'll have log absolute here. You'll have 4 log absolute here. Okay? Now all we have to do is remember Vegas and undoing Vegas's derivative. Vegas, 2x plus 3 here. Vegas, 5 minus x here. The derivative of Vegas is 2. I need to undo that. The derivative of Vegas is negative 1. I need to undo that. Done. Yikes. All right, same deal. Find f given f prime. So I'm going to start with e to the parentheses and then 2 cosine parentheses. Antiderive the outside, antiderive the outside. Vegas, undo the derivative. Negative 2nd power, negative 3rd power. Antiderive the outside. Four times negative 1/2. Vegas, undo Vegas's derivative. All right, we got -1 over 2, 2x plus 3 to the first. We got 2, I'll keep it up, move 5 minus x squared down. I have a plus c. Cool? You see this and you freak out, but don't forget about simplifying. If I divide everything by x squared, what do I get? Remember doing this? Power rule. This is x to the negative second. X to the negative first times -1. This is 2x to the negative first. 2 log absolute x. There's no chain here, so you don't have to worry about it. 3x, 4 x squared times a half times 2 plus c. Okay, so that's that. Okay, we did this in class. Remember what the derivative of a number to the x power is. It's a number to the x times the natural log of the number. This is a number that comes out of the derivative. This is tricky for a lot of students, but watch. Let's say I think that the antiderivative is 2 to the x. Like I'm taking the antiderivative. Let's say that I think the antiderivative of 2 to the x is 2 to the x. Well, that's not true because the derivative of 2 to the x is 2 to the x log 2. Let me show you. The derivative of 2 to the x is 2 to the x times the natural log of 2. So if I take the derivative of this, I don't get that, okay? I get 2 to the x times the natural log of 2. Well, I want to get rid or undo this extra natural log of 2. What do I have to do? Multiply by the reciprocal. Just like why we need these 1/5 and these 1/4 and all these like reciprocal numbers so that they go away. You can write it like that. You can easily write it as that. But that's it. It's like e to the x divided by log e. It's like I don't need the log e, but we could have been putting it there the entire time. I don't know why I put this here. It's like making sure you understand. It's almost like we should have done this first to making sure why you undo it. So like, for example, taking the derivative of e to the 3x is e to the 3x times 3. So we got e to the Vegas times the derivative of Vegas. Log. This is the 3 that we're undoing with undoing the derivative of Vegas. What I was talking about. Log parentheses. Its derivative is 1 over parentheses. 3x minus 2's derivative is 3. So I have 1 over Vegas times the derivative of Vegas. This is that 3 that we're undoing. If I ask you to find f prime of 2, okay, whatever, just plug in 2. Many of us are kind of beyond the O's and the I's, so let's see. E to the Vegas times the derivative of Vegas, derivative of the outside, Vegas, derivative of Vegas, e to the Vegas times the derivative of Vegas. The derivative of the outside is the important thing. I bet you a lot of people, if you don't use the O's and the I's, you don't put cosine, especially when we have e's where it's like nothing changes. But like sine's derivative is cosine, don't forget that. So, Cantor, e to the 2x plus 4 cosine 4x plus 2x e to the x squared. I could factor out a 2 if I wanted to. Plug in 0. You get 2 plus cosine of 0 is 1, 4 plus, oh, that's a 0. Six. Ugh, these are annoying. Honestly, these are like, if you do half of these, I'm okay with it. It's the next 2 lessons and the next 2 homeworks I need you to spend more time on. If you spend less time on this homework, I'll give you a check plus, okay? So if you're watching this thing, because it's really just repetitive. It's very repetitive. Only thing is like differential equations, we're finding C, okay? I mean, I don't even ask you to find the missing value. And that's okay. A lot of the test questions you're going to see is just find f of x. Okay. I got 4e to the parentheses. Its antiderivative is 4e to the Vegas. Undo the derivative of the Vegas. This is a good one to do because the last 2 lessons, more differential equations, where you just, your answer is an equation, and you will see e's in them, and you'll see e to the zeros in them, and you'll have to be okay with finding c. Plug in 2, it should equal 4. 16 thirds plus c equals 12 thirds. C equals negative 4 thirds. Many people think that C is the answer. C is not the answer. It's the equation with the found C is the answer that we're looking for. If you just like stop here, that's fine. But like on a free response question, which you're going to see, you need to write down the final equation. All right, 5 cos parentheses anti-derive the outside, 5 sine parentheses, Vegas, undo Vegas. This is f. F of pi over 2 is 3. So I have 5 halves sine of pi over 2 times 2 is pi, which is 0, plus c, that has to equal 3. So c is 3 because that's 0. I mean, this is good practice for, you know, using numbers, getting answers. This is a good one. I'd rewrite it as 4 parentheses to the negative first. Antiderivative 4 natural log absolute. Undo the derivative of the inside plus a c. F of 2 is negative 2, so f of 2 is negative 4 log 1 plus c. The natural log of absolute 1 is 0. This means c is negative 2, so f is negative 4 log 3 minus x minus 2. This is like a test question, just heads up. You're plugging in this weird thing, 3 minus e. Watch what's going to happen. Start by rewriting this as 4 parentheses. I already did it. I already did this. So f is negative 4 log absolute 3 minus x plus c. But here I got 3 minus e equals 5. Okay.
Are you going to that side?
Subtract. It works out if you don't do this.
Side, what'd you get wrong?
3 minus e. And this plus c has to equal 5. Now, 3 minus 3 minus e becomes e.
I don't you know,
Natural log of e is 1. C equals 9.
he's super busy right now.
Oh yeah. Sorry.
You can tell that I circled these, so I feel like I should get full credit. Yeah, I got him right at some point while I was.
Oh my gosh. Second order differential equations. Every step along the way, you need a C. Yes, we're on that side.
We're on that side.
All right. We're taking the antiderivative of negative 1 half e to the parentheses. Negative 1 half e to the parentheses. Antiderivative of negative 1 half e to the parentheses is negative 1 half e to the parentheses. Vegas, undo Vegas. That becomes a positive 1/4 e to the negative 2x. Antiderivative of 2x is x squared. Antiderivative of 3 halves is 3 halves x plus c. We are told f of 0 is 2. Get 1/4 plus 0 plus 0 plus c equals 2. 8/4 c is 7/4. We have 5 minutes. I can crank this out. Sine parentheses, antiderivative is negative cosine parentheses. Okay, so going backwards one step, I got negative cos parentheses plus c. Vegas, undo Vegas's derivative. That negative stays, I just turn this into like a fraction. F prime of 0 equals negative 1/3 cosine 0 plus c, which has to equal 2. C has to be 7/3. Great. Go back another step. F, we got negative 1/3 cosine parentheses. Its antiderivative is going to be negative 1/3 sine parentheses. Negative sine's derivative is negative cosine. Vegas and undo Vegas. That becomes a negative 1/9. 1/3 times 1/3. F of 0 is 3, C is 3. Sine of 0 is 0, 7/3. Gosh. All right, cool. These are important ones. Vegas, undo Vegas's derivative. That's a 1/10. Plug in 1 that equals negative 3. I get negative 1/10 plus c equals negative 3. That's negative 30/10. Plus 1/10 is negative 29/10. Jeez. Find f of 2. F of 2 equals 1/10 times 1 to the 5th minus 29/10, which is negative 28/10. Negative 2.8, negative 14/5. Vegas, undo Vegas, antiderivative e to the x is e to the x. C 7/4. What's f of 3? 1/2 e squared plus 7/4. Leave it. F of 0 is 2 to the 0 over ln2 plus c. That has to equal ln2. I don't know if this works out as nicely as I thought it would be. C must equal ln2 minus 1 over ln2. What's f of 1? If I plug in 1, it's 2 over ln2 minus 1 over ln2, which is 1 ln2. If I have 2 1 over ln2s and I subtract 1 over ln2s, I have 1 over ln2. And I think this is my final answer. This is not a problem you're going to see on the test. This is something that you will see on the test. If I go backwards, antiderivative of sine parentheses is negative cosine parentheses. Vegas, undo Vegas's derivative. What would that look like? Negative 1 over pi. If I plug in 0, oh, great. The cosine of 0, pre-calculus students, you'll learn that that's going to be 1. I'm going to leave it at that. You're good. We got to understand this for the future, but the next 2 lessons are the big lessons of the unit. So this will help us for the next 2 units. Expect to have longer homeworks for the next 2 lessons. Be ready for it. All right, I gotta go teach some units. So I'm teaching unit circle to the pre-calculus kids. Isn't that exciting? Here we go. Later.